In this problem, you have a 12-volt battery connected in series with a resistor that has 12 ohms and an inductor with 3.5 henries. You're asked to figure out how much time it takes for the current to reach 50% of its final value. So we have two equations here that deal with RL circuits. This one is for when we start at, say, like 0 current and then we increase to a maximum value. This is when we start off at some value and then we decrease the current to some bottom limit. So this is the equation that we want to use. All we have to do is plug in what we know to it. So then I is equal to, let's just rewrite it, E over R 1 minus e to the negative RT over L. And what we want is 50% of its final value. So you should hopefully remember that this is equal to I max, or I final. So then I want I to be equal to E divided by R times 1/2 because I want 50% of that value. So then I just rewrite it like this. And then you can straight away see that these two cancel out and you get 1/2 is equal to 1 minus e to the negative RT over L. I'm trying to figure out how much time this took, so I'm going to have to rearrange some stuff. First thing I can do is put e to the negative RT over L on one side, and that's equal to 1 minus 1/2. Take ln of both sides, so then I get negative RT over L is equal to ln of 1/2. From here, T is equal to ln 1/2 over R, can't forget that minus sign, and now I just plug everything in, right? Just gonna move question B down. So then to get my final answer, I have T is equal to negative, and then of course L is 3.5 henries times ln of 1/2 divided by the resistance, which is 12 ohms, and that's going to give me 0.202 seconds. Okay, so that's how much time it took me to get to 1/2 of my final I max value. Now you're told that after a very long time, I is equal to I max. So we've let it reach its maximum current, so the inductor is not really doing anything. The battery is then removed. In what time interval will the current decrease to 50%? Well, we should know that if it takes 0.2 seconds to increase, it should also take 0.2 seconds to decrease. But let's go ahead and prove that by using this equation here. Right, so the I is equal to E over R, e to the negative RT over L. So I'm just going to rewrite that here. And remember that I now want a 50% decrease. So here I want my I to be equal to, again, 1/2 E over R is equal to E over R, e to the negative T over tau. So these two cancel out again, and I get 1/2 e to the negative T over tau. So it's 1/2 is equal to that. ln on both sides, ln 1/2 is equal to e to the negative T over tau. And then I get T is equal to, I use tau here. Tau is literally just L over R, so it doesn't really matter what you want to use. But it's negative tau ln 1/2, where, like I said, that's just L over R, ln 1/2. We literally already did this. This is 0.202 seconds. So the only kind of difficult thing about these problems is one, kind of like knowing what's happening and that you can use these equations. Also knowing that E over R is your maximum current value, and knowing how to say, well, okay, if I want 70%, how do I write that out? Like here we wanted 50%, so it's just E over R times 1/2, right? And that is pretty much it for this problem.